So this video is going to focus on geometric sequence, meaning a pattern of multiplication. It is a sequence in which each term is separated by multiplication of a constant for each term. Now, before we look at the equations, we really need to understand the vocabulary. And if you watch my video from arithmetic sequences, this is the same slide. So just remember that in arithmetic, as I mentioned there, would be like adding 5, where geometric would be like multiplying 2. But A1 still means the first term, A5 would still mean the fifth term. So in this sequence, 1, 2, 3, 4, 5, it would be 32. The 20th term, you would write out a whole bunch or use the formula. So AN is any term. It also means the formula for the sequence. It could also mean the last term. And commonly, the formula is sometimes called the rule. So AN minus 1 is used. We now understand from doing arithmetic that this is for recursive. It means the term before, and occasionally you'll see AN plus 1, which would be the term after. And you could have like AN plus 3, which would be 3 terms later, but typically you just see these two in formulas. So the difference between arithmetic sequences and geometric sequences is that arithmetic, you add or subtract something and you have something called the common difference. And remember that the common difference is found, right, by taking any two terms. So we'll just start with the first two. You take A2 and you subtract A1, hence its name common difference. The common ratio is called the common ratio because you would, instead of subtracting them, you would divide them. A2 divided by A1. Now, that being said, there's a very important thing about geometric sequences that you need to keep in mind, and that is that the common ratio can only be described as multiplication, okay? That means that division must be written as a fraction. So let's say I had a sequence like this. Let's say I had 27, and then 9, and then 3, and then 1, and then so on. Well, the R is a third, and if you can't find it, because sometimes it could be like 5/3, okay? The way you would do that is you would find R would be the second term divided by the first term, or any term. I mean, I use A2 over A1 because you always, you typically have a list of numbers. You could do the third term divided by the second term, or the fourth term divided by the third term. As long as they're right next to each other, they have to be directly following each other, and you divide the second one divided by the first one. So in this case, we would get 9 divided by 27, and that would, of course, reduce to a third. But you can see right here, 1 divided by 3 is also a third, and so is 3 divided by 9. So that's important because when you look at the formulas, the explicit formula is AN is equal to A1 R to the N minus 1. AN means formula or rule, or any term. A1 means the first term. R is the common ratio, which you just saw me find, and N minus 1 is the exponent. So this equation is identical to the exponential function f of x equals a b to the x. And if you want to go back and watch that video, it might help you understand exactly what's going on. There's only one difference, okay? And that's the exponent is n minus 1 and not just n, because, this one's x. We still have the whole decay and growth thing going on. We call it slightly different words in this chapter, and there's a major implication later for that. So the recursive is also part of this, and the recursive is just like for arithmetic. You state A1, and then you say that any term, the formula, is equal to R times the term before, or R times A n minus 1. So if you had a sequence that was something like 1, 5, 25, and so on, right? In this formula, I'm just multiplying by 5. What I would do is I would put 1 here, and then for the second part, I would literally just put a 5 right here. It would just be 5 times a n minus 1. And once you do that, they can actually combine recursive, which we'll look at, meaning you can actually, recursive, one of its powers is you can combine arithmetic and geometric by just simply adding on a d here. So if I were to add on d, you could have a combination of both, which there is no explicit formula for that. And we'll look at that in some of our examples. So let's take a look at some examples that will help us understand how geometric sequences work and how to write their equations. So the first problem here, we're going to interpret these sequences and determine whether each sequence is geometric. If so, we're going to identify the common ratio, determine if it is convergent or divergent, and then write the explicit rule for the geometric sequence. The first thing I think we should talk about is what is the convergent and divergent? What is that talking about? So for something to be convergent, it is exactly the same as exponential decay. Okay, a convergent series is a series in which the R value is between 0 and 1, right? So remember, the way we say that in math is two less than signs. Now, the absolute value is going to take care of a negative if there is one, which is important because the first problem has an R value that's negative. For something to be divergent, that is going to be the exact same thing as exponential growth. And so if you remember, that would be R greater than 1. Okay, so let's see what this one is. Well, when I look at it, it appears that I'm multiplying by something. So it appears that it probably is geometric. So let's see. The way we find that is the common ratio is the ratio of any two terms that are right next to each other. I like to pick the first two, but you could have easily just, instead of saying 2 and 1, you could have 7 and 6, as long as they're adjacent terms. So in this case, we would get 15 divided by -3, and so that is -5. So you might have looked at it originally and said, oh, I think it's 5. But see the alternating, see how it goes from negative to positive, and then negative, the next one would be positive again. That tells you that R is negative, and that explains why we have the absolute value in here, because if we don't have the absolute value, you might say, oh, that's less than 1. But the absolute value gets rid of that, and we find out, oh, this is divergent. Okay, and so that answers the first couple questions there. And then the next thing it says, is it geometric? I think we established that it's geometric by finding the R value. So let's answer that. Yes, it's geometric. And then it wants us to write the equation for this. Okay, so the equation is just AN is equal to A1 R to the n minus 1. And all we do is just put the numbers in, right? AN is equal to A1, which of course is the same thing that we had before, it's just this first term. And so that would be -3. And R we already found, right, because R was -5. And then the n minus 1 is just part of the formula, just like it was for the arithmetic. Now the one thing that students have to watch is thinking that they can combine this to make it 15 or something. Please keep in mind that these don't have the same base. So the rules for combining exponents, which is what this formula is if I have the same base, I combine the exponents. I don't have the same base. And if I have the same exponent, I combine the base. I don't have either of those situations. So this formula rarely simplifies. Okay, the only way to simplify it is if these two are the same base or have the same exponent, which will never have the same exponent. So be careful. All right, so on our second problem, it looks like it's getting smaller. And when things get smaller, that means we actually have a fraction. So for this problem, let's see what R is. So R is going to be A2 divided by A1. So R is 4 divided by 16, and that is a fourth. That's pretty evident once you look at the next two terms, because it would just be 1 divided by 4. And so this one meets the requirements for convergentness. Now that is a term that, again, it just means decay in the world of sequences. But this is very important for later. There's a formula that we're going to look at in the series world for geometrics that will need this to be convergent in order to use the formula. So that's why we're kind of getting that concept understood now. All right, so this one's a yes, right? We just proved that it's a fourth. And the formula would be AN is equal to A1 parentheses R to the n minus 1. And so that means that AN would again be, find your first term, blammo, it's right there. And then what we do is we just write that down, 16, we put our R value in that we found to prove that it was geometric, and we have our equation. Now in this one right here, you can just leave this like this. But later in more advanced classes, you might find a way to simplify this, because 16 and 4 actually share a base. But in Algebra 2, just leave this alone. Basically, do not simplify that. Okay, so when you get these equations, leave them alone. All right, so now we're going to find just given equations. We're going to learn how to use them to produce sequences. So in number 3 here, they gave us a formula, and they say, hey, given the explicit formula or recursive geometric formulas, find A of 5. And of course, you could iterate this, but we've kind of learned that it's really not a great way to do it. I mean, if you want to do that, you're going to have to start at a1 and you're going to multiply 3 by 7 each time. And that's how you'll do it. A more efficient way to do it would be to just say, well, I need to find a of 5, and that'll give me 3 to the negative 7, 3 times negative 7 to the 5 minus 1. And you would want to reduce this, okay? So you can reduce this part right here to the fourth power. And then you realize, wow, these geometric sequences are going to be enormous because we're multiplying, and we really need to employ a calculator. So I'm going to use Desmos since it's free and web-based. So we would just take 3. We would multiply by negative 7. Remember, that would alternate the terms if we did look at them all. And then we're going to raise that to the fourth power, and we see that we get 7,203. And that's a big number. So you definitely don't want to try to do this by hand. But I want you to notice that if I did do it by hand, I would go from 3 to negative 21, and then I would go to a positive, and then a negative, and then you can see this term right here is positive. So use the formula when you can. Remember that explicit formulas allow you to go directly to the answer, where recursive formulas don't. Now, one thing I want to make a note to you about this recursive formula is this recursive formula that I have here is actually part geometric and part arithmetic. And that's one of the reasons we learned it as well, because to combine arithmetic and geometric, it's basically impossible with an explicit. Not impossible, it is very outside of the realm of Algebra 2. So that's why we introduced geometric, because it allows this possibility of having multiplication and addition. So it wants me to find the fifth term, so let's iterate. You have to iterate with recursive. There's no alternative. So we have A1, A2, A3, A4, and A5, and then we're going to start with 2, always given to you. And think of this thing as basically what you plug in. An minus 1 is like saying this is x. So this is like saying f of x is equal to negative 3x plus 5, but it's not the same as x because you're not plugging in 2, right? You're actually plugging in this term. So you're plugging an output into here, okay, into this value. So x is maybe the wrong letter. We'll just use a parentheses. And then we're getting that answer. So let's see what that looks like. If I plug 2 into this thing, I get negative 3 times 2 plus 5, right? That's negative 6 plus 5, and that will give me A2. That gives me negative 1, okay? To do A3, I plug negative 1 into the formula, and I get negative 3 times negative 1 plus 5, and that will give me 8. And I keep doing that, right? So I plug 8 into the formula, and I get negative 3 times 8 plus 5. That's going to be negative 24 plus 5, or negative 19. And then I plug negative 19 into the formula, right? Negative 19 plus 5. And that's going to be negative 3 and negative 19 make positive 57. And then plus 5 makes 62. So the answer to the question is A of 5 is 62, but it's kind of interesting the way it works is because you're using a formula, but instead of plugging in inputs, Recursive actually has you plug in the previous output. So A1 is 2, and then 2 is what goes in. So it's like a composite function. It's more like f of g of x. But it's not exactly the same, so it's its own thing called recursive. In this video, we're going to look at examples that expand our knowledge of how to write the equations of geometric sequences. And we're going to start by finding something called the geometric mean. And the geometric mean basically is referring to missing terms. In this case, they want 3. So you have 1, 2, 3 missing terms before you get to 4. Start at 1,024, end up at 4, and then we need to figure out how to get there. And this is going to require us to find r. Well, we learned in the previous examples that r is found by taking A2 divided by A1, but I don't have A2. But what I do have is I have A5. So you can actually do this, okay, doing the same idea, finding, remember, the common ratio. So the ratio in this problem would be 4 divided by 1024. Now, the problem is we have to remember that we're taking A5 and dividing A1. So because those aren't adjacent, when they're adjacent, it's simple. You just divide and you're done. And the reason is you don't need to do any additional math. But remember, we're doing an exponential equation. So the way you undo an exponential is to take the square root of its exponent. And so to simplify this fraction, I also need to root the difference of these terms, in this case 5 minus 1. Now, a lot of students will see that and like, that looks complicated. It's really not that bad, but you're going to have to use a calculator clearly. But they also ask, why didn't you do it over here when you did A2 divided by A1? And the reason is the root there would be 2 minus 1, and that would be the 1 root, which isn't a thing, right? The 1 root is just raise it to the first power. So it doesn't matter when they're adjacent. It only matters when there's gaps between the terms you're dividing. So let's take a look at how to find this common ratio. The first thing we're going to do is divide 4 divided by 1024 to reduce that fraction. If you're using an online calculator like Desmos, there's a little toggle button here. It says convert to fraction. So that's 1 over 256. And so this comes out to the 4th root of 1 over 256. And if you are using a regular, Casio or TI calculator, there's root buttons on those as well. So what we're going to do is we're going to take this answer and we're going to do the in root, right, which would be 4, and then we're going to put in here 1 divided by 256. I guess you could have put the original thing in there if you wanted, and that will toggle to a 4th. So what is the R value in this problem? It is a 4th. How did I get it? I used the values they gave me. I used iteration to determine I used iteration to determine how far away they were. And then I found the difference of their how far away they were. I turned that into a root, and then I did their division just like I would in a normal R problem. So now that I know that R is a 4th, I'm just going to come over here and multiply by a 4th. I'm going to multiply the next term by a 4th, and I'm going to multiply the next term by a 4th, and then I'm going to multiply it by a 4th, and hopefully I will return to 4. So 1024 times 1/4, or divided by 4. Remember, you can't really say divided by 4 in the formula, but if you want to think about that when you're going from term to term, that's fine. So 1024 times a 4th is 256, and 256 times 1/4 is 64. And 64 times a 4th is 16, and sure enough, 16 times a 4th is 4. And so it's kind of nice, you always get the answer that they gave you in the problem as a check. So the reason we learned that is we're going to need it when we start looking at writing recursive and explicit formulas given information. So in this first problem, we're just given a problem, and we're going to learn how to write the explicit formula for it, and then the recursive. And then over here, we'll have to do a little bit of extra work to find R. So let's just review that concept of how to find R again. In this problem, to find R, what we're going to do is we're going to take A2 and divide by A1. And the reason we don't need a root is the root would be 2 minus 1, which would be the first root, which is actually raising something to the first power. So we luckily in this problem can just divide 9 divided by 6, right? A2 divided by A1. And that, of course, will give 3/2. And so that's our R value. And then to write the explicit is just incredibly easy for geometric. It's AN is equal to A1 R to the n minus 1. And so once again, A1 is given. Now notice over here it's not. So that's why we had to learn those other things. So what we're going to do is we're now going to say AN is equal to 6 times the R value that I found right here, 3/2, and then the n minus 1. And again, just leave this formula alone. Don't simplify it. There's your explicit. Leave it alone. To find the recursive is always to state A1. A1 is 6. Just like you do here, you say 6. You have to do the same thing here. And then you say any term after this is to multiply the term before, so n minus 1, and then you multiply that times the R value, 3/2. Some people put it in a parentheses instead of a multiplication. Some people put it in a parentheses and use multiplication, whatever you want to do. All right, so that's the first two parts of the of that problem. The next thing it wants us to do is, could you find A10? And the purpose of that is to realize, okay, if I'm going to find A10, I'm going to use this, right? I'm not going to use recursive because I'd have to do this 10 times. So to find A10, we're going to use specifically the explicit formula, and that will be 6 3/2 raised to the 10 minus 1. And I always like to tell students, make sure you actually simplify easy things before you type it in the calculator, because it's actually just less frustrating to type into the calculator to the 9th power. So let's take a look at that. That's not something you can do in your head. So 6 and then parentheses 3/2. And then make sure you're clicking out of the parentheses, even if you are using a calculator that's handheld. And then you raise that to the 9th power, and you get a crazy number. But if you toggle this, you get that. Now, I'm going to show you something interesting that you can do as well that I think is important. So one of the answers is that fraction, right? So that fraction is 59,049 divided by 256. So one thing that students don't know about how numbers typically work on a calculator is, let's say I wanted to write that as a not improper fraction. I wanted to write it as a mixed number. The way you would do that is you would want to find what this piece is. And so what's beautiful about a calculator that's like Desmos is you can literally just copy that, hit enter, and then put it here, and then toggle the fraction on that. You have to hit enter. Now, it didn't let me because there's missing decimal points, but if it let me, the toggle would come up and it would work. Now, one way to force it to do that would be to take this and then subtract off the 230, and then you get that decimal, and then it will allow you to toggle. So that problem is actually 230, 169 over 256. And it's an interesting, I think it's an important thing for you to learn how to do, because sometimes writing it as a mixed number is required, or on, especially on an SAT or something, sometimes they just give you those tricky kind of answers that are exactly what you have, but they just decide to take it a step further just because, they're trying to make sure you're paying attention or something. So again, the way that I did that was I took the answer and I realized, well, I've got a 230 here. And if I subtract that out, it'll leave me with the decimal that's behind it. And then that decimal that's behind it was converted. So yeah, I have that same decimal, which is more decimal places. And then it would allow me to convert it to 169 256. Just an important calculator skill that you maybe don't know about. All right, so how do we do number 7? Well, let's just start trying to write out the equation and see what we're missing. And unfortunately, for the explicit formula, an is equal to a1 r to the n minus 1. We're actually missing everything, right? We don't have a1 or r. So we learned when we did this geometric mean problem that we can find r between any two terms as long as we use a root that shows their difference. So in this problem, to find r, what we're going to do is we're going to come over here and we're going to say, okay, they gave us a7 and they gave us a4, and to find r, I would divide those because it's a common ratio, but I'd have to root the difference between the two. So 7 minus 4. So in this case, r will be the third root of the ratio 192 divided by negative 24. And I wouldn't trust, I just wouldn't trust your brain on this. You're going to want to make sure you're using a calculator. All right, and so 192 divided by negative 24 is going to be a negative number, which makes sense. Okay, so we end up getting -8, so we actually can do the next part ourselves. And so remember how roots work. If this were a square root, this would be a problem because it would be imaginary, but the cube root of a negative number is a negative. That's a very important thing to remember in algebra. Odd roots are negative, even roots are problematic. So if you needed to do that, what you would do is you'd come here. If you really wanted to know what it was, you'd say cube root of -8. If you don't trust your memory, then sure enough, it is -2. So now we can put that back into the equation. Okay, so the equation is now going to give us an is equal to a1, and I now have this little piece of information, right? I have -2. So how do you find a1? Well, I could iterate and then work backwards, or I could use the fact that the formula actually means any term. So to find any term, what you're going to do is you're going to take a little break over here and use the formula in that way. So you're going to say an is equal to a1 negative 2 to the n minus 1. They gave us several terms. They gave us 4 and 7, so we'll use a4 just because typically math is easier if you use smaller numbers. I will say that if a7 were a smaller number, I probably would have used a7. All right, we're solving for a1, so we'll just leave that there. We have a negative 2 here, and then here we get to put a 4 minus 1, and that's how this will work. a4 is defined as negative 24, so I put a negative 24 there. a1 is multiplied times negative 2 to the third power. Negative 2 to the third power is negative 8. And then all I do now is just divide by negative 8. And once I divide by negative 8, I get that a1 is 3. Pretty neat how you can do that. So now we finally have our final equation for the explicit formula. The explicit formula is an is equal to 3 times negative 2 to the n minus 1. So it's interesting how you can use the formula to find missing pieces of the formula before you know the answer to begin with. Now, to do the recursive, all the information is already given to us right here. So the recursive is saying find a1, we have that, and then find an by multiplying by r, which is r is negative 2, and then times, an minus 1. And so if you look at this, this is why people will say, okay, we need a multiplication sign here. Some people will use a parentheses. It just doesn't matter, okay? a1, of course, we need to state what that is, and that was 3. So here's your recursive, okay? And then the last thing it says to do is to find a of 10. And so a of 10 is found by using the explicit, and this again is just a calculator exercise. It's actually an identification of which formula to use exercise as well. And so a of 10 is 3 times negative 2 to the 9th. And that's just going to be an enormous number. It could be positive, it could be negative. Let's take a look at what it is. So to do this one, we would have 3 and then a parentheses negative 2. And then we would raise that to the, make sure you click out of that parentheses or else it won't, it'll try to do it inside, to the 9th power. And that comes out to, not too big, negative 1,536. Negative 1,536. So not so bad. Just make sure that you're using a calculator with these kind of problems, and make sure that you understand how to find r using a common ratio and a difference of the root. And make sure you remember that an means any term. So if they give you any term and you know r, you can actually always find a1, because the term number will reduce the exponent, and the term value will allow you to find a division and get the answer.